Hi there everyone, and welcome back to week 16 of the Maths Tutor exam countdown. So as always, you will see a link to two videos in the chat. This week we're looking at coordinate geometry, the line, which is always a very prominent part of paper 2 in the Leaving Cert higher level. So the two videos this week, for any of you that are non-members, the first one there is looking at the area of a triangle formula, where the formula comes from, the derivation of it, and some examples. And the second one looks at a line in general form, ax plus by plus c equals 0, and it just investigates the slope and the y-intercept and goes through a couple of examples there also. So hopefully you find those of some use to you. And we're just going to jump straight in. So as you can see here, I have a picture of the log tables from page 18 and the top of page 19. So we're just going to go through a little bit of that to start with. I suppose up here at the top, it's very, very important. It tells you how to label your points. So every time you get a question in coordinate geometry of the line, we label our points and we normally sub into one of the following formula. So to start with our slope formula, y2 minus y1 over x2 minus x1. And I suppose slope is one that's quite important in coordinate geometry. There's three ways of finding slope, and it always comes up in some form or other. The first way, if we're given a diagram, so if we have a picture of the line, we can generally find the slope as rise over run. So that's if we're given a diagram of the line. If we're given 2 points on the line, we can find the slope using our formula here from the log tables, page 18, y2 minus y1 over x2 minus x1. And finally, if we're given the equation of the line, we can find our slope by getting y on its own at one side, and the number there in front of the x will be your slope. So you see that down here on your log tables on page 18 also. So slope, just to run through that very quickly, three different ways of finding it: diagram, points, or if you're given the equation of the line. The second formula there then is your distance formula, distance or length. And it's not always going to mention the word length or distance in the question, but we need to recognize that those two lines, so either side of PQ or AB or whatever the points are, that means distance is what we're looking for. The third one is your midpoint. So those first three formulas are from the Junior Cert course. Number 4 is your equation of a line formula. And I suppose the one thing to remember there, you need two things. The first thing you need is you need to know the slope of the line. And the second thing you need to write the equation of a line is the point on the line. And then the last 4 formula are only from the Leaving Cert course. So just throw those into a different colour. There's your area of a triangle. So like I said, that video in the chat, the link is in the chat there, and that video goes through where this formula comes from and how we use it. And the one thing to remember about this formula is one of the points must be at 0, 0. So one of the corners of the triangle must be at 0, 0, and if it's not, we must translate the 3 points. So translate 1 to 0, 0 and move the other two in the same direction. This one here, that's our division of a line segment in a given ratio. So just to bring it out here, in this case, we will have a line with a point P, which we'll call x1, y1, a point Q at the other end of the line segment, which we'll label x2 and y2. So that's using the labeling notation up here. And we'll be basically looking for a point somewhere along that line segment that divides the line in the ratio A is to B. Okay, so A is to B there. And the last two formula then are at the top of page 19 of your log tables. We have the perpendicular distance from a point to a line. So your point is x1, y1, and your line must be in that general form. And that's quite useful in the line and the circle on paper 2. And the last one is our angle between two lines. So I'll just bring that out here again. Basically what we'll be looking at here is we'll be looking at two lines intersecting. We will know the slope of the first line, we'll call that M1. We'll know the slope of the second line, we'll call that M2, and it'll be the theta in the middle that we're looking for. And again, your plus and your minus there determine whether it's the acute or the obtuse angle. So obviously you have that obtuse angle between the two lines there also. Okay, so that's just a very brief introduction to your formulae in your log tables. Obviously, you don't need to remember any of those formulae. You just need to know how to use them. So we're going to start off very, very basic today. We're going to start off by actually looking at a junior cert question. Just to kind of get us into the swing of things, and then we'll move on to a couple of leaving cert questions. So we're starting with the junior cert higher level paper, paper 2 as always, and it is question 8 from the junior cert paper, remember. So the equation of the line is that, and the first thing we're asked to do is find the slope. So as we mentioned previously, if we're looking for the slope when we're given the equation, we have to get our line in this form, y equals mx plus c. And once we do that, the number in front of the slope, the number in front of the x, will be the slope, and this constant at the end will be our y-intercept. So in other words, where that line crosses the y-axis. So we're going to take our equation, and we're going to try get y on its own. So I'm going to try keep the y positive, and I'm going to add 3y to both sides. So that will give me x minus 6 is equal to 3y, and I'm just going to flip that around so that I have the y on the left. So 3y is equal to x minus 6, and then I'm going to divide across by 3. So I'm dividing everything by 3. Those will cancel, and we'll be left with y is equal to, so there's an invisible 1 there if you like, 1/3 x minus 6 over 3 is just 2. So now that we've gotten it in the form y equals mx plus c, don't forget to write down your answer. Your slope is the number in front of the x, so your slope in this case is m is 1/3. So remembering to finish out the question, they've asked you for your slope, so make sure that you answer it. Part 2, show that the point 1 minus 2 is not on the line. So we're checking if that point 1 minus 2 is on the line, but we're expecting it to not be on the line. So all we're going to do is we're going to sub into the line, x is 1, and everywhere I see a y, I'll put in minus 2. And remember, it's this line here, the line from part 1 we're using. And let's see what happens with the left and the right. So x is 1, y is minus 2, and I'm leaving everything else as it is. Now, when you work out the left-hand side here, that can go straight into your calculator, you will end up getting 1, which we know is definitely not equal to 0. So since the left is not equal to the right, we need to conclude and we need to say, therefore, 1 minus 2 is not, as we expected, on the line L. And again, remembering to conclude here, they've asked you to show that the point is not on the line. So we must write our conclusion. We must answer that question, okay? The reason it's not on the line is because when I subbed it in, it didn't satisfy the equation. The left wasn't equal to the right. And part 3, the line K passes through 1 minus 2 and is parallel to the line L. Find the equation of the line K. So if I go back up to my log tables here, very quickly, we're looking for the equation of a line. So that was this one here. And what we need is we need a slope and we need a point. So we'll just go back to our question. And the first thing we'll write down is our formula. Y minus y1 equals m bracket x minus x1. So let's think for a minute. Have we got everything that we're looking for? Well, we have our point, which is x1, y1. So that's the point. And indirectly, they're giving me the slope. So they're telling me it's parallel to the line that we had up in part 1. So if it's parallel, that means that they're going to have equal slopes. That's what makes two lines parallel. So for example, there's parallel lines. They're heading in the same direction. They'll never meet. And it's the slope being equal makes them parallel. So we have our point. Our point is 1 minus 2. And now we have our slope as well. It's the same as the answer from part 1. So that's going to be 1 over 3. And we're just subbing into our equation. So we have y minus y1. So that's going to be y plus 2 is equal to 1/3 times x minus 1. Okay. And at this stage, we're going to multiply out the brackets. But before we do, a nice little trick here. If you have a fractional slope here, a nice little trick is basically to take that 3, and what you're going to do is, because the 3 is on the bottom, you're going to multiply across by 3. So you're going to multiply the whole thing, everything across by 3. And what that should give you on the left is 3y plus 6. On the right, when you multiply by 3 and you're dividing by 3, that's just going to cancel out and give me 1x minus 1 when I multiply out the brackets. So essentially, if you like, you're taking that 3, you're moving it across, and you're multiplying by 3 at the left. Okay, and we're pretty much done there. They haven't asked us to give the equation in a particular form, but it is really good practice maybe to get it in general form. So I'm going to move everything to the right. I have a 1x, I have a minus 3y, I have a minus 1, and I have a minus 6 there. Okay, so that was 1 minus 2 was our point, and 1/3 was your slope. And we're equal to 0, so that's 1x minus 3y, and when these two go together, we get minus 7 equals 0. And that's us done. Nice and easy. Okay. I suppose, look, that's just to kind of ease us in, and it goes through a lot of the basic things with the line. So you will see it steps up a little bit of a gear when you get to the Leaving Cert higher level questions. So that's what we're going to have a look at now. First of all, we're going to look at a question from a couple of years ago. This is 2015. Again, it's paper 2. The line is always paper 2. And this is question 3. So the first thing we are asked is, or we're told, we're given the coordinates of 2 points, A and B, and the line L is perpendicular to AB. Find the value of T. So you can see here, they're giving you 2 points. They're leaving out one of the coordinates. They're calling it T, but they're giving you this really interesting or really useful piece of information to make up for it, which they have to do. If they leave out something in a question, which they have done, they have to give you an extra piece of information to make up for that. So we're told that the line is perpendicular to AB. Now, anytime I see the word parallel or perpendicular in a question about the line, I always have to think about slope. I should always be thinking about slope. So what we're going to do, we're going to start and we're going to find the slope between these two lines, or these 2 points. Then we're going to find the slope of that line, and then we'll worry about them being perpendicular. So starting with 4 minus 1, that's going to be my x1, y1, and 7t, that's going to be my x2 and my y2. And I'm going to use my formula, because I'm given the 2 points, I'm going to use my formula to find the slope of that line. So we're starting with the line AB, if you like. So subbing in, that's going to be y2 minus y1, that's going to be t minus minus 1, so t plus 1, over x2 minus x1, which is 7 minus 4. So t plus 1, can't do anything with that on the top. 7 minus 4 on the bottom is 3. And that's as far as we can go with that one, because we don't know what t is. But then we can find the slope of the line L1. So that's 3x minus 4y minus 12 is equal to 0. And our aim is to try get that y on its own. So I'm going to add 4y to both sides. And that will leave me with 4y is equal to 3x minus 12. And then I'm going to divide across by this 4 to get the y on its own. So everything gets divided by 4. And we end up getting y is equal to 3/4 x minus 12 divided by 4 gives us a 3, or minus 3 in this case. So let's have a look. What we've worked out is the slope of AB is t plus 1 over 3. And the slope of the second line is 3 over 4. Let's just make a note of that. They don't give us a whole lot of room here. But the slope of the line L1 is 3 over 4. And we know from our studies that if 2 lines are perpendicular, so there's our symbol for perpendicular, then one slope, M1 we'll call it, times the second slope should equal minus 1. So that's our test to check if 2 lines are perpendicular. We know for sure these 2 lines are perpendicular, so we can just say, well, t plus 1 over 3 times 3 over 4, they must equal to minus 1. So simplifying, just move over here a little bit so we have a little bit more room. We have two fractions, t plus 1 over 3 times 3 over 4, two fractions multiplied by each other. We're going to multiply top by top to give me 3t plus 3, bottom by bottom to give me 12 equals minus 1. And then we're left with an equation with one unknown t, which is what I'm looking for. So I'm going to multiply across by 12. So we end up getting 3t plus 3 is equal to minus 12. And it should be nice and easy to solve that equation. We end up getting t is minus 5. Okay, now there is another way of going about that question. I suppose once we got to here, the first slope and the second slope, what we could have done is we could have taken this slope, and we know how to get a perpendicular slope. We flip it and we change the sign. So m perpendicular would be minus 4 over 3, and we could just equate those two slopes then because they're perpendicular. Okay, either way is fine. You're getting most of the marks there for getting your two slopes in the first place. Okay. Second part, find in terms of k, so there's going to be a k in our answer, the distance between the point 10k and the line L1. So k is going to be in our answer. First thing we're going to do is write down our formula from the top of page 19. That's the absolute value of a times x1 plus b times y1 plus c over the square root of a squared plus b squared. So my x1 and my y1 come from my point, and my a, b, and c, they come from my line when it's in general form. So that's going to be my a, my b is minus 4, and my c is going to be minus 12. And it's a matter of just subbing in straight into this formula. So it's going to be the absolute value of a is 3 times x1, which is 10, plus b is minus 4, times y1, which is k, plus c, so that's going to be plus minus 12, or minus 12, over the square root of a squared plus b squared. So that's going to be the square root of 3 squared plus minus 4 squared. And simplifying on the top line there, we end up getting 30 minus 12 is 18. And this in the center here, minus 4 by k, is going to give me minus 4k, and that's in the absolute value signs. And the bottom can just go straight into your calculator. So this part here, square root of 3 squared plus minus 4 squared, that's going to give you 5. Make sure that minus 4 is in brackets. Okay, so the distance from the point 10k to the line L1 is absolute value of 18 minus 4k over 5. And part C then builds on that question. So it tells us that 10k is on a bisector of the angles between those two lines. Find the possible values of k. So I'm just going to take over here and I'm just going to draw a little diagram. We have our line L1, and now we're introducing a new line L2. And we're talking about the bisector of the angle between them. So there's the angle between them. And a bisector is one that cuts it in half. So that means that that angle and that angle there are the same. And one theorem that we do on our course, just extend those a little bit more, is, so we have a point 10k on that line, on the orange line, which is the bisector of the angles, and that point P is on that line. We're told that here. And one theorem we do in our course is basically we look at the perpendicular distance from that point to either of the lines, and it's basically going to be the same. So the distance between P and L1 will be exactly the same as the distance between P and L2. But look at what you've done. Up here, you've already found the distance between P and L1. So down here, we need to find the distance between P and L2 in exactly the same way. So my point is my x1, y1, and my line is my A, my B, and my C. And we're going to use exactly the same formula as we did in part B. So coming from page 19 of your log tables. So that's going to be the absolute value of 5 times x1 plus 12 times y1 plus c, which is minus 20 in this case, all over the square root of 5 squared plus 12 squared. And again, that can just go straight into your calculator. On the top, in your absolute value, you're going to get 50 minus 20. So that's going to give you the absolute value of 30. And then we have plus a 12k. So it's the absolute value of 30 plus 12k. And on the bottom, we should be getting 13. So this works out to be 13. So that distance there, if I go back to my diagram, I suppose, that's this distance between P and L2. And what we found up here is this distance between P and L1. But we've just said those two distances should be exactly the same. In other words, my answer from part B, which was absolute value of 18 minus 4k over 5, that should be exactly the same as the absolute value of 30 plus 12k over 13, which we've just found. And because we have one fraction equals to another here, we can cross multiply. So on the left, we'll get 18 times 13, and that should give you 234, minus 4k times 13 is 52k, equals 5 by 30 is 150, 5 by 12k is 60k. And again, I can't just drop my absolute value signs, so they should still be in place. Now again, you have a choice here. We could square both sides and that will get rid of the absolute value signs, because remember, those absolute value signs, we know that whatever's inside them, it has to work out to be positive. Okay, so we square both sides to get rid of the chance that it might be negative in there. Or another way of doing it, probably the shorter way, which is what I'm going to show you here now, we could drop our absolute value signs and we could say, well, that 234 minus 52k on the left, that could either be equal to 150 plus 60k, so the positive of what's on the right. Running out of a little bit of space here, but we'll go with it. Or the left, 234 minus 52k, could be equal to the negative of what we have here. So that would be minus 150 and minus 60k. So we're minusing the whole right-hand side. And from there, it's just a matter of you solving your equation. So in this first one here, I'm going to make sure that all of the k's are on one side and all of the numbers are on the other side. So I'm going to make sure all the k's are at the left. So I'm going to subtract 60k from the left, and that will give me minus 112k. And I'm going to subtract 234 from the right. So that should give you minus 84. And then to get k, it's going to be minus 84 divided by minus 112. We should be getting k is 3/4. There's one of my answers. And have a look at the question. It looked for possible values, so we expected more than one answer. And in the second equation, so this one down here, when we add 60k to both sides, we end up getting 8k at the left-hand side. And when we subtract 234 from both sides, we end up getting minus 384 at the right. So your k ends up to be minus 48 is your second answer there, as we expected. So my writing is quite big here, that's why I've run out of space, but yeah, you should be fine, I think. And the last part then, if k is a positive number, so let's look at our positive value of k. It was this one here. Find the distance from P to L1. So let's remind ourselves of the distance from P to L1. That was this answer here from part B. It was the absolute value of 18 minus 4k on top with 5 on the bottom. And we're letting k equal to the positive value that we got in part C, part 1, which is 3/4. So it becomes the absolute value of 18 minus 4 times 3/4, and we get 5 on the bottom. Yeah, so we're just throwing that straight into the calculator, and we are getting, your answer should be 3 units. So we don't have units here. So 3 is fine for that answer. Okay, so getting through a good few of the formula there. We had the perpendicular distance formula, we had our slope formula, all wrapped up in that question. Okay, so we should have time for another question. 2014 sample paper 2 is this one, and it's also question 3. So the first part, show that for every value of k, a real number, that point is on that line. So this is similar to the junior cert question we had. That's going to be my x, that's going to be my y coordinate, and we're simply just subbing in. So it becomes 3 bracket 4k minus 2 minus 4 bracket 3k plus 1 plus 10 is equal to 0. Now, unlike the junior cert question, the point wasn't on the line. We're hoping that everything is balanced here and the point satisfies the line. So we end up getting 12k minus 6 minus 12k minus 4 plus 10 is equal to 0. And as you can see, your 12k's cancel out. We end up with a minus 6 minus 4 plus 10. They also cancel out, so we get 0 equals 0. And remember, I said to you, make sure you conclude. So we can say, therefore, P lies on L1 or something to that effect. P is on the line L1. And we're given a diagram there, and it shows that P is on the line L1. Part B, the line L2, so a different line, passes through P and is perpendicular to L1. Find the equation of L2 in terms of K. So it's an equation that we're looking for. So straight away I write down my formula from page 18. Y minus y1 equals m bracket x minus x1. I need two things. I need a point, but we're given a point. It's the point P, so that's 4k minus 2, 3k plus 1. So that's going to be my x1 and my y1. And it's perpendicular to L1. So indirectly, that's telling me that if I know the slope of this line up here, I'll be able to find the slope of this second line L2. So taking that line, it's 3x minus 4y plus 10 equals 0. And our job is to try get y on its own. So I'm going to add 4y to both sides, and I'm going to divide across by 4. So we're getting 3/4 x plus 10 over 4, or that simplifies to 5 over 2. So because it's in that form, my slope is 3/4. So therefore, my perpendicular slope, because that's what's needed for line L2, we're going to flip it, so turn it upside down, and we're also going to change the sign. So it becomes a minus 4 over 3. And now we're good to go. We have our point, we have our slope, and we're just going to sub into our equation of a line formula. So that's going to be y minus, be careful, put that 3k plus 1 in brackets because the minus comes before it, equals minus 4 over 3, bracket x minus, and again 4k minus 2 in brackets because of that minus before it. So getting rid of the brackets, y minus 3k minus 3. I'm going to leave that minus 4 over 3 there for a second, and I'm going to work out this bracket. So we're getting x minus 4k plus 2. And like I said to you in the junior cert question, we're going to, because it's a fractional slope, we're going to basically multiply across by 3. So when we do that, we get 3y minus 9k minus 9. And the minus 4 multiplies everything on the right-hand side. So minus 4x plus 16k minus 8. Simplifying, I'm just going to bring everything to one side. So we're going to leave everything, leaving the x as a positive, everything on the left. We get 4x plus 3y minus 25k. And we have, sorry, I've actually made a slight little mistake up here. I don't know where I got that 3 from. That should still be a minus 1. So when we multiply across by 3, that should be a minus 3. And that should give us a plus 5 here equals to 0 at the end. So apologies about that. For some reason, I put in a minus 3 there instead. But it should have been a minus 1. So our equation of L2 in terms of k is 4x plus 3y minus 25k plus 5 equals 0. Okay, and part C says, find the value of k for which L2 passes through the point Q, which is 3, 11. So I'm just going to go back up to my diagram here, and I'm going to mark in that on the diagram. So remember we said P is any point on that line because we don't know what k is. So we're saying that that point, which is perpendicular to L1, is passing through the point Q as well. So we know for sure that this equation that we've just found in part B definitely passes through that point Q. So we're going to basically sub in 3 for x, 11 for y, and we know everything should balance. So it becomes 4 bracket 3 plus 3 bracket 11 minus 25k plus 5 is equal to 0. So that's going to give me 12 plus 33 minus 25k plus 5 is equal to 0. And that should, when we solve it, and we leave k's on one side, numbers on the other, we should end up with minus 25k on the left equals minus 50 on the right, telling me that k is equal to plus 2. So that's the value of k for which the line passes through that point Q, 311. And part D, hence or otherwise. So hence normally means that you use your answer to the previous part, or otherwise we can do it in another way. Find the coordinates of the foot of the perpendicular from Q to L1. So if we look at, there's the perpendicular from Q to L1, and we're looking for the coordinates of that point right there. So this is my line L2, and we're basically looking for where it intersects with L1. So if we take L1 from our very start of the question, it was 3x minus 4y. Let's just remind ourselves, 3x minus 4y plus 10 equals 0. And L2, which is this line that we had up here in part B, that was 4x plus 3y minus 45 equals 0. So where did that minus 45 come from? Well, we know that k is now 2. So that's going to give me minus 50 here, plus 5 is minus 45 equals 0. And because we're looking for the point of intersection, we're basically going to do simultaneous equations there. And in short, so I'll leave you to do your simultaneous equations, but you should end up getting x is 6 and y is 7. So the point, the point or the coordinates of that point are going to be 6 and 7. Okay, so again, I haven't gone through the simultaneous equations. That is the otherwise way of doing it, and there is another way of using your previous answer. Okay, but either way is fine. Either way will get you your marks. So hopefully that was of some use to you guys, and I'm very sorry about that mistake in part B there, but we copped it just in time. And it's really good practice. This week was basically just all about practicing with those formulae from page 18 and page 19 of the log table. So the questions will get a little bit harder. Okay, thanks for tuning in.